Hi everyone, welcome to the session, which is going to be the last topic that we will deal in this introductory series of learning how to program in Python. So the topic we'll be dealing with in this session is the object-oriented programming concept. This concept helps us to develop programs that are manageable, and it helps us to develop programs that can be easily debugged if their error occurs. And one of the chief benefits of object-oriented programming is encapsulation, which have been introduced to you when we were dealing with functions in the last session. So you divide this in this encapsulation concept may allow you to divide your program into pieces, and each piece internally operates independently of each other, and the pieces interact with each other, but they do not need to know exactly how each of the pieces accomplishes the task they do in the program as a whole. So developing an object-oriented program-based system requires some planning and setup time. So before you start coding, you have to design the entities that are within your system. What are the classes you have, and what are the functions within each classes? What are class variables? These are things you have to plan to develop a object-oriented based program. And so it is actually not appropriate for short and small programs. Most of such programs which we have used in examples in this series. So however, I will cover the basics of object-oriented programming here and use our program with I will demonstrate this with a small program that plays a die game with 2 players. So this will give us a kind of feel of what object-oriented programming is. I will recommend you to watch out for my videos on object-oriented programming with Java that will be coming up later. So if you are interested in exploring more, and you may also pick up any book on programming or software design to learn more about designing program in an object-oriented manner. So let's go to our Python editor to start exploring object-oriented programming and see the basic concept of it, so that at least this will stimulate our interest in exploring deeper. So object-oriented program is a concept, is a design where you have you define the entities, the classes within your program, for example, and you have to define the classes, and you will have the class variables, and also the functions or methods which define what the class can do, the functions or method of the class. If you don't understand these terminologies at this stage, just take a deep breath. We'll explain them further, and we believe it will get clearer as we go on in this session. So we have been using the concept of object-oriented design in our coding, and most of the ones that we have used has been the inbuilt classes that Python has defined for us. For example, if I define a string, my string, and I say my string is John, my string the value in my string is John. Let's look at string class defined for us in Python. You can see this is string class in Python. This is the string class in Python. The items of a string are characters. So the string class, and these are constructors, how you can create a string. This is how you can create a string. This is how we have created a string. Literal syntax: initialize a new instance of string type. Just initializing a new instance of string type like this, and we will declare a string. So there are methods that you can use with the string. For example, find. It returns the index of the first occurrence of the string search for. For example, if I use my string dot find, let's say I want to find O in my string. So this letter O in my string, it will return the index of letter O in my string. This should be 1 because this is 0 and this is 1, this is 2 and this is 3. So it will return the index, the position of that letter in my string. If you look, see now, it gives me 0. So these are methods that you can call from a string object. So this particular string is an object of the string class that has been defined for us in Python. This is an object of the string class that has been defined for us in Python, and we have the methods that we can call with the string. For example, the split method we have been using returns a list of words in the string separated by a delimiter. So what you use to separate it. So if I have a string, if I add this string as John Owell and I use split and I ask the split to use the delimiter space, so this will return a string. Let's print this. It will return a string with 2 elements, John and Owell. Elements in index 0 will be John, element in index 1 will be Owell. If you look at this now, I have to run this again because it was John, then I print. So it has John Owell. You can see how the split method returns the list of words in the string with a delimiter. Assuming I have this here, I can declare that the delimiter is this, and I run this, it will still give me the same thing because I have this delimiter. And if I have this as the delimiter, I can say what separates the 2 words is this, and I can run this and it will give me the same value. So you know what it means by the delimiter now. So there are many other functions and methods that you can that change all the variables to uppercase. So I can say my string dot upper. So if I run this now, you can see it changed all the variables to uppercase. So this just returns the variable in uppercase. If I actually want to change my string to uppercase, I can say my string is equal to my string dot upper. That's when everything is changed to uppercase, and you print my string again, it will be in uppercase. You can see that. So that is about class, the string class that the Python has defined for us. So there are other built-in class. The list also is a class that the Python has defined for us. Let's look at the list class. So this is the list class. So you can create a list by assigning the literal syntax by actually saying list this. If I have use this list conversion function, convert object into list. So we can create, these are the 3 ways you can create lists. This is called the constructor, and we have method with list, which is for example insert an item at a given position. Insert an item at a given position. Let's see how they use this insert here. So insert item at a given position. So you can say insert that means insert the at insert 0 at position 0 in the list, and this one says insert 1.5 at position 2. So let's look at this. For example, I have a list of number list, and I say this is 1, 2, 5, 6. This is the list. I can say number list, my number list. So this number list is an object of the class, so I can call any function in the class that has been defined for us. Insert, let's say insert at position 2, and I want to insert number 3. So if I run this now and I print number list, you can see position 3, as in the value 3 has been inserted to position 2. So this is a method from the list, the class list. So this is a method from the class list. You can see there are other methods you can call, but with the object of string, remove, pop, index. You can explore this and see other methods you can call and how these methods actually works. So this is a brief idea that we have been using classes, inbuilt classes that Python has defined for us, and we have been calling methods of these classes. So you can create your own class. For example, let's have a class defined students. Let's define a class of students, and let's say how will you create each class of students that you have. You can create the class of students by using this keyword init. This is a constructor, and always remember this keyword self in every method of a class. The first argument is self, and let's say the variable name and age of student defines the variables of students, and you can say self name is equal to name given, and self age is equal to age given. So you can also define other methods. Let's say method get name will be return self dot name, and we can say def method get age will return self dot age. So say we have another method set name self, which we get a new name, and we'll have this self dot name is equal to the new name. And let's say we have a method also set age, and we have self and new age. This will now make it self dot age is equal to new age. So we have defined the classes, the class student. This is a definition of the class student, and if I run this with this, now I can create objects of students anywhere in my program. Let's say student 1 is equal to student with name Carlos Rantos and with age 33, and let's say student 2 is an object of students with the name Rajiv Bak, and is 24, and another name student 3. We have students, we have Aisha Bello, and is 44, and we have students, and we have Adekunle Adeniran, and let's say he's 13. So if we run this now, we have been able to create names as in different objects, 4 objects of our student class. If I want to call method of this object, I can say print student stud1 dot get name. If I print this stud1 dot get name, remember this whenever you call a method. So can you see, gives me the name. If I say stud1 dot stud2 dot get name, you can see it gives me the name. I can call stud print stud3 dot get age also. So calling a method, remember these 2 parentheses in front of it. You can get the age, you can get the name. We can also add this to the method, is a special method to the class. So let's call it str and self. So we can say print name plus this dot name plus n plus age plus self dot age. So this define how, if we call print, how our class can be printed. So if I say print stud1, it will give me print stud1. So the age is an integer, so converted to string. So we can now use that to print the object. So this actually define how this special method define how object of this class will be printed. It defines how object of this class will be printed. You can see now I have defined a class student, and I can create students class and print, get their name, get their age, or print them, which will give us this. If I print student 2, it will give me the details of student 2. If I print student 3, it will give me the details of student 3. So a quick one, we can also use the set name method to change the name of the student. Let's say we have student 3. You can see that the name was Aisha Bello, and I call the set name. You can see the set name method as defined here. The set name takes in an argument, which is a new name, and it now changes the new name to the in the method. So it changes the name of the student object in the method. Let's look at the set name method. Takes the new name. It was Aisha Bello. Let's call it Maria Bello now. Let's call the student 3 Maria Bello now. So if I call this, this should be a string, remember. And if I call this method and I do this print 3 now, you can see this has changed from Aisha Bello to Maria Bello at 44. If I use set age, takes a new age argument to change the age of the object. Let's assume I call set age now. Set age on the object student 3, set name on the object, so the set age on the object student 3. Then I now change the age to 53. Then we can run it, and if I print this student object again, it has changed the age to 53. You can see how we can use the set name and set age that we have defined here to change the name of the object of this class, the object of this class that we've created. So this is the concept of object oriented design. Here we have defined the class students. The variables are name and age. The function, the first function is the constructor. So this is the constructor. This shows you how you will create an object of a student class constructor. And this special method tells the interpreter how to print the object of student class, and this method returns the name variable of student class, and of an object of student object, the name variable of student object. And we have this one returns the age variable of student object. So we create the class as a template, the template of creating an object. So if we have the template, it's like you have an architectural design and you can build many houses based on that design. So the class is a design, the objects are the houses that you are building, so with the design. So those houses can have different colors, they can have different sizes, but they will have the same variables, age and name that you have defined. So in creating this student class, you cannot add address because we have not defined address as the variables of that student class in the class definition. So I think this gives us a hint about what class and object means. Let's look at a smaller example. Let's say class simple add calculator, add calc. So this add calc, you should in creating object of it, you should include two numbers, a and b, and you can now say in initializing the variables, class.a is a, self.b is equal to the b. And let's say we have def addition, add self will return self dot a plus self dot b. Let's say we have def multiply, this will return self dot a multiplied by self dot b. Let's say we have also def divide, this will return self, the first argument, divided by the second argument of the constructor. So def subtract, so this will return self dot a minus self dot b. So let's assume we define this class a simple calculator, and let's say my calc is equal to simple calculator, and the numbers that I'm putting in to initialize, let's say, is 3 and 20. So let's say 3 and 20. Then I can call all the functions with my method. Let's say I want to print my calc dot add, right? And also print my calc dot multiply, print also my calc dot, let me copy this, my calc dot divide, and I can multiply, divide, and copy this, lazy typing. So my calc dot subtract. So if I print all this, let's see what it gives. You can see we have 320, it adds it to be 23, it divides it, 3 divided by 20, 0.15, and it multiplies it 3 times 20 with 60. It subtracted 3 minus 20 is minus 17. So we have built a simple calculator that can add, divide, and subtract by calling the method. Just create the calculator, and with the constructor having the first argument and the second argument, which is the variable of the objects, and you can call the addition, the division, the subtraction. If we change this to 20 and say we have 3 here, and run this and do this again, you can say this is going to be 23 addition, 20 divided by 3, which is 6 point blah, 20 times 3, which is 60, 20 minus 3, which is 17. We can now put in any of the variables, and it will give us something, the values that we want in terms of adding, dividing, multiplying, and subtraction. So you have seen how we've created the class simple calculator, and we create the constructor for it. This is how you define the class. For example, if I didn't put this, if I just said this, it will throw an error. Can you see? Calculation, the simple calculator in it, that means the constructor missing one required positional argument. So the constructor has defined for us what we should add when we are creating. So that's the template of creation. Then if you have created it correctly, then you can just call any of its method to divide. You cannot call a method that is not defined in this. Let me say modulo. It will tell you modulo is not, object has no attribute modulo, so that's not a method in the class. For example, if I now define modulo, let's say def modulo, modulo self gives me returns a modulo self dot b. So if I run this, it will work because modulo is now part of the methods that you can call with the object of that class. That's I think it's gives us an idea of what what a class, object of class, the variable of class, the methods of a class. So here, this is the class, simple add calculator. Let's call it simple calculator now because it's not only adding. So the constructor here, you can see this is a keyword for constructor, is a special method that tells us the way you can create objects of this class. Then this is a method that returns addition of the variables. You can see these are the variables of the classes initialized by the constructor. Then all others are objects as the methods of the classes, function of the classes, object of that class can call. You can see I gave an example of another special method here which defines how the class can be printed. So we didn't define this kind of method here. If I print this, if I try to print my object, my calc, it will give me something calc, as in my calc is not defined. Let me see, let me redefine this. I've changed this to add calc. Let me redefine this. Simple calculator. I don't think, okay, simple remains, we don't have L there. So let me recreate that method and have it created here. Run this work, but let me try to print it and see what error it gives us. Print. Can you see? So it doesn't have a definition of how to print it. Doesn't have the definition of how to print it. So let me add this and show you. So this special constructor is defining, if we call print on object of this class, this is what you should return. The variable one, return variable one is a self dot a, and variable 2, my writing, that my spelling, variable 2 is a self dot b. So, and let me convert this to string. So I want this to be in a new line, so I think this is okay. String. So this is how I want my object of my class to be printed. And if this still works, and if I print this now, it will give me variable 1 and variable 2. So I think variable 2 here we didn't give a much space, so let's run this again. So good. So you can see that that method actually defines how object of my class calculator can be printed. I believe this gives you a kind of tips and idea of the concept of creating classes, defining the variables of the classes, defining the method within the classes. To create a class, we need the keyword class. You can see there is a keyword class telling the interpreter that this is a class. Then this is the name of your class. The name of the class, it's all to you to define the name that actually describe your class. And the first method in the class is called the constructor, which has this keyword in it. You can see the double stroke, double underscore in it, then double underscore after. And another keyword that you may define in your class is a string keyword, double underscore string double underscore, which defines how objects of your class can be printed in the print with using the print function. Then, or you can define other methods within your class which tells the interpreter the methods that your object of your class can call and what that method will do. That is a brief, a basic introduction to class to object-oriented design. Let's create an example of a small complete program using object-oriented design. So let's create a dice game. The dice game that is played by two players. And so what in the dice game, each player will take turn to throw dice, to roll dice, and their score will be added. So there will be initial score will be defined, and the first player to reach the initial winning score, the winning score will be declared a winner. So if a player cannot, the score of a player cannot be more than the winning score. So if a players roll dice and the addition of their score will be greater than the winning score, then that particular score, then the score for that particular roll will not be added. So let's work on this, the dice game for two players. So the first thing we have here is that the entities in this requirement is there must be a class for players, and there must be a class for play game. Let's use those two classes. So, and secondly, there should be roll dice. A player should be able to roll dice and get a particular score. So we want rolling a die, we need to create a random number between 1 and 6. So let's say we want to import random, and I want to create my class player. So in my class player, this is the constructor. So the constructor will request for the name. So it's not, if we won't create it directly initializing the name, so we ask the constructor to request for the name, which is the variable of that class. Please enter a name to play. So request for the name. So the second variables of that player class is the score, which will be initialized to 0 when they start. So another method with this is let's say roll die. A player should be able to roll dice. So roll dice. Remember, for any method of a class, you include the self as the argument. Roll will become a random number, will give us a random integer between 1 to 6. So that's a random method that creates a random, that picks random value between 1 to 6. So whatever it's being rolled, self score will become plus the roll. So the score of the player will be added to the roll. The score is initialized to 0 initially, then you roll. You return the roll for that. So let's create another one, get name method. So get name method, actually what does it do? Return the name of the player. And let's create another one, set score, and reset the score of the player is equal to s, so it can reset the score of the player. And let's say we have another one, get score, which return the score of the player, return self dot score. So this is my definition of the player class. This is my definition of the player class. So this is, then we can now create another class which I call gameplay. So inside the gameplay, for any gameplay, let's define the constructor in it. So this we have solved. Then we must define the winning score, the winning score for this game. And we have self winning score is equal to winning score, also is equal to this. So that's one variable of the gameplay. Then another variable is that it must have two players. We have, so that means we will create an object of the player class. Player 1 is equal to player, so self player 2 is equal to player. So it must have two players and the winning score. So after creating the class variables, we have the variables winning score, we have the variable player 1 and player 2. So that is in the constructor, that is, those are initialized in the constructor. Let's now create one single method in this gameplay. Let's call this play game. So in this method, what happens? The first thing that happens is to determine whose turn to play first. Let's say turn. This turn is a random choice between the player 1 and player 2. So that's whose turn to play first. Random choice between player 1 and player 2. So we say while true, so the game continues until something happens to break it or to end it. While true, we say roll and prompt the player that has the turn to roll die. So the player that has the turn, we will get the name by saying get name of the player, and we ask the player to roll, enter R to roll dice, right? Enter R to roll dice. So we now check if the player actually enters the right character R. If it will continue with the play, else we will prompt the player that this is an please enter R to roll. So please, or we can say invalid input, it will still prompt to enter R. So let's leave it as invalid input. Now that is what happens if the user enters invalid value. So now if he enters the right thing, what we do, we get first the previous value, the previous score of that player turn. The player in turn gets score, getting the previous score. Then we now implement the roll, turn dot roll dice. So if the player in turn roll dice, then we'll print the roll, turn dot get name, roll the following, so the R, right? And now we check if what the player rolls, if get score now has been added to, as in the role has been added to the get score based on our definition. If get score is more than right, if get score is more than winning score, then turn dot set score back to the previous. You can see reason why we got the previous score. Now if the role takes the score more than the winning score, we go back to the previous and we tell the user that the player that the total score is over winning score and not counted. So this role is not counted, then the turn is changed. So print the score now. Score is still your score is turn dot get score. So the score is being revert as in changed at that time. What else? So now that is if the score is over. So if the score is not over, we will say if turn dot get score, if turn dot get score is equal to self dot winning score. So we print game over and tell who wins turn dot get name 1, right? Turn dot get name 1. And what happens here? Break. You break the loop and the game ends. You break the loop and game end. Else if this doesn't happen, then the game will continue. If the game will continue but the player must change, the next player will change. So if turn is self dot player 1, right? If turn is self dot player 1, turn becomes self dot player 2, right? Else turn becomes self dot player 1. So that's where the turn changes. So I think this defines it. Let's see. So we have only one function in the game, and let's try to see. We have defined the player. So let's try run and play our game. Play game. So we create an instance of game 1 is equal to play game, and we have to define the winning number. Let's say the winning number is 20. Then we start playing our game by calling the method play game, right? We call the method play game, and let's run this. It asks for us to enter name. Let me enter this one, TJ, and the second name, let me enter DJ. So it asks TJ to enter R to roll a die. Assuming I enter L, it says invalid input. TJ, enter R to roll a die. So it asks TJ, let me enter R, and it breaks. What happens? Self. So it is self. So I like this live writing, so that you see the kind of problem, the kind of errors that you can make. So here we have slave instead of self. Let's go to where the problem is. So this is where we have the problem now, self. So let's run this again. Run. So let me enter the first player name TJ, the second one DJ, and I roll the die. So my score is 2 now. Can you see it changes to DJ's turn? So DJ also rolls the die. DJ roll 1, and it changes back to TJ turn. TJ rolls the die. TJ roll 4. TJ roll 2 again. Then the score is 4. Then it changes back to DJ time. I roll. So DJ rolls 2, and his score is now 3. So TJ rolls another time. The TJ score is 5 this time, added to the previous score is 9. And the next one, DJ rolls 1 again, and the score is 4. Now TJ's turn. TJ roll 5 is 14, and now DJ's turn. DJ roll 6 becomes 10. TJ's turn. TJ roll 5. TJ gets to 19, and DJ's turn. DJ rolls. DJ gets to 16. TJ's turn. TJ roll now. TJ rolls 2, which takes TJ's score to be over 20. So your total score is over winning score and not counted is not correct. We will do that one later. So TJ's score still 19, and DJ roll 5, 16 before, so it's over the winning score. That one is not counted too. TJ rolls again, are still over the winning score, so the two of them are on the verge of winning, rolling over the winning score. TJ1 rolls 1 now, and it goes to 20, and that is game over. Your score is 20, game over. TJ1. And that is a description of how to write a good kind of interactive game. You can see our dice game looks a bit interesting. So we have the player class defined, we have the gameplay class defined, and this is now working together. You can see that the player class is all a variable inside the gameplay class. So the design is like we have let me show something. I want a class, create a new diagram. I want class diagram, and let's have here we have player class, we have a name. So we have name. So let me see. So we have name of player. What other thing do we have here? We have name, and for players, and score. So we have player name and score, and those are the variables. And for the methods we have let's see, we have roll dice, get name, set score, get score. So for the method we have roll dice, we have get name, we have also set name. All right, do we have roll dice and get set score, and we have the score S, and we have get score. So in this we have and in the gameplay we have variables winning score. We also have variable player 1 and player 2, and we have only one method in there, which is play game, right? And if we want to draw class diagram of that design, this is a simple way to describe the design. So we can show that this is a class object of player, and used in this game play class. So we have two classes, player and game play. So that's just an idea of the design description of what the game is, and you can see how quite interesting. So that's the end of this tutorial series. I believe you have one or two things that you have gained in this series. It's a series for introductory level. It's a series for someone who do not have a basic knowledge in programming, and it's a very good way to start up. And I hope I have been able to stimulate your interest in learning more about programming, learning more about developing software either in Python or exploring other programming languages out there. So I will beseech you to actually subscribe to this YouTube channel, because I'll be dropping more videos on different topics. After this, I will be working on graphical user interface with Python, which is a GUI with Python. Here you will learn how to build GUI applications, and where you have button clicks. All this gameplay might be with button clicks and text box entry. So here we'll be looking at GUI components with Python, and also before then, also for more advanced programmers, I'll be dropping an expository on NumPy construct in Python. That's a module in Python that is often used by people who are into data analysis. So it has been an interesting journey so far. Please subscribe to this YouTube channel so that you can receive notification when other interesting tutorial video drops. Join me on Facebook at Collab Learn, and also if you have any feedback or comment, you can contact me via collablearn2024@gmail.com. I believe that you have actually learn one or two things that will make you explore deeper and learn better. For now, thank you very much for listening, watching, and I will say again, happy exploring.